Dhairya, can you please introduce Hurudaya, sir?
Yes. Good morning and hello, everybody. So, today for our session, we have Hruday sir, who has completed 2 years at CMI, pursuing a dual degree in maths and computer science. Now at Kriya University, Hruday sir continues to explore interactions between math and computer science in fields such as graph theory, logic, and game theory. So, without ado, we'll start the session.
Thank you for that introduction. Before I start today's lecture, I just want to say I want my session to be like quite interactive. Most of them will just be like fun puzzles that we'll be solving. I don't want you to like raise your hands or anything. You can just like unmute yourself in the middle and talk to me. Just like any doubts you have or like any observations you see, you can just like interrupt me in the middle. Feel free at any time. Also, I probably will not be able to see the chat, so if you have any doubts, try to unmute. Otherwise, like one of the TAs can unmute and let me know. I'll just get started quickly. Can everyone see my screen?
Yes, sir.
Okay. So let's start with a simple exercise first. So you guys had Ashwin's session yesterday, so you saw chessboards and everything, right?
Yes, sir.
Yeah. So all of you are familiar with how a knight moves?
Yes. Sir.
Okay. So now I have a task for you guys, okay? So I'll clear the board. So I have a knight on the bottom left corner, and I want you to get it to the top right corner of the board, okay? I want you guys to find some. I want you guys to find like the smallest number of moves in which you can do this, going from here to here, okay?
So the answer is 6, sir. I think.
Okay.
Yes, sir. Even I
Right.
get six.
6 more.
Six.
6. 6, sir.
Okay. So you've all found a
6.
path to do it in 6 ways, right? See, in 6 moves. But I'll just demonstrate
6,
it in
sir.
case like anyone wants to confirm. But like you can go here, here, 3, 4, 5, and 6. So we have a path to go from there to there in 6 moves, right? Uh, but what guarantees that there's no solution less than 6 moves? Why are we confident that 6 is the smallest number?
So if we want, we can also start from the other L side, sir. Like, we can also start from C3, sir. I think. No, not C3, sir. C2, sir.
C3
We
is
can
here.
also start from. Sir, we can also start from C2.
Yeah,
sir.
I mean, we can do the symmetric thing. Yeah. Like we can do something like this is what he's saying. But yeah, I mean, that's just symmetric, right? But like, yeah, so we've seen that there is a path. There is a path to go from the bottom left to the top right if you're using 6 moves. But all of you were very confident in telling me that you had to do it in 6 moves, right? Like that's the minimum number. Can anyone explain why you think it's the minimum number?
Like that can be possible if we get two options, the both options are same, so probably the whole answer should be the.
Can you repeat what you said? Sorry, I couldn't exactly understand what
Yeah,
you said.
like we tried two ways now, so
Yeah,
uh, from the two ways we get the answer at same six. So
yes.
probably all the answers.
I mean, I can also do it in more than 6 moves, right? Like, one,
Yeah, you
two.
can do it more than 2 ways, but the less answer, like minimum answer will be.
Yes, that's what like everyone's saying. My question to you is, why do you guys think the minimum answer will be 6? Why not 5 or 4?
So because when we go closer to the night, when we
Hmm.
go closer to the other night, it takes at least
Hmm.
4 steps to go closer. And then
Okay.
we notice then we can't jump directly on the night. Then we take 1 step to rearrange ourselves, and then we go to the top right.
Yeah, that's kind of how we were doing this, because if you go here or here, then you'll have to do this. Yeah, that's kind of how we were doing it for this solution. But that's not exactly a proof that there isn't a shorter path that none of us are seeing, right?
Sir,
Does that make sense? Yeah.
sir, probably, but this is one thing I noticed. Like, if
Hmm.
imagine the knight were a bishop, and then it had to get to the other knight, it had to move along the diagonal, which is
Yeah.
like in the middle of the bishop and the knight, there would be
Hmm.
like 6 squares. That's one thing I noticed.
Yeah, there would be 6 squares, yes.
So probably that would be like.
Yeah, like that's a really nice observation. Okay, but here's my thing. If the knight was here, like if we're trying to go from here to here, right?
Yeah.
Then you have 1, 2, 3, 4 moves, right? You can go from
Uh-huh.
here to here in 4 moves.
Yeah.
But there's like 5 squares in the middle on the diagonal, right?
Yeah.
Yeah. Every path we've seen so far has had 6 moves, right? Can you guys try to find some longer paths to the knight, like back to here? But yeah, can you guys try to find some longer paths and tell me how many moves it takes?
Sir, can I say, sir, Abhinav? Sir, I can do it in 5, sir. 5 moves.
Okay, tell me how you do it in 5.
Sir, first to C7. C7.
C2, you mean?
And then E6.
E3, okay.
G5.
G4 this is, but okay, yeah.
Oh, wait. What?
Hmm.
Huh? Okay.
Yes, someone else
G4.
had an argument.
So I have a longer path.
Okay,
Sir, I
tell
have
me the
longer
longer
path.
path.
Sir,
Yeah.
C2,
C2,
B4,
B4,
C6,
C6,
D8,
D8,
E6,
E6,
F8,
F8.
G6, and H8.
That's 1, 2, 3, 4, 5, 6, 7, 8. Perfect.
Sir, I have longer path, sir. Sir, I have a longer
Okay.
path. Sir, I have a.
Okay. Yeah, let's go one by one. One of you tell me.
Sir, sir, C2,
C2,
A, A3,
A3,
and then C4,
C4,
A5,
A5.
C, like that continue,
Yeah.
9, and then this. And then now D, um, D, no wait, E7,
Okay. E7.
then C, C6,
You wanna just do this again?
yeah. And then for the other row also.
Something like this.
Yeah.
But then after this, what do you do?
Sir, then you can reroute, sir.
And then do something like this, right? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24.
Sir, actually, you can jump on all the squares before going to that night.
That's the next question. We'll get to that. Give me 1 second.
So
Okay.
basically, you can get to 63 squares and then jumped on the last knight.
Sir,
Uh,
sir, I have a doubt.
okay. Yeah, what's your doubt?
So, like, are we allowed to like visit a square more than once or something? Like more than
Yeah,
once
you
or two?
can. Like, for example, this solution visits like the square, all multiple times, right? Like all of these squares. You're allowed to visit it more than once.
Sir, then there are an infinite number of solutions you can do like that.
Yes.
So how are we gonna count them?
Sir,
We're
I
not
also have.
trying to count the solutions right now. We're just trying to see what the shortest path we can find is, right? And
Okay.
what a lot of you guys are claiming is that it's 6. We're just trying to see whether it is 6, and if it is 6, whether we can prove it's 6. Okay. So,
Sir, I have a longer path.
okay, so I think that's enough paths for now. If you have if you have any arguments for why you think why you think 6 is the shortest path, or why you have a shorter path, then tell me right now.
Sir, I have an argument.
Okay.
Sir, over here we can notice that with the pattern that you use, it moves 4 spaces along the line, or 3
Yeah.
spaces along the line in 2 moves.
Yeah.
And so if we do that twice, we get to the 6th space. So we need to move 2 more spaces to get to the knight. So we just reroute once over there. We reroute once, and then we take 1 turn to get back, and then we take 1 turn to go to the knight.
Yeah, that's quite. Yeah, that's what most of our paths were doing. We either got to like here or here, and then we rerouted, and then we went there. My question is, but this doesn't prove to us that that's the shortest path, right? That's just the path we've been taking so far.
Sir, like
Yeah.
the for us to go through the diagonal, there are totally 6 boxes, sir. So the
Yes.
horse can travel like only till G7. It can travel, sir, in 4
Yeah.
moves. After that, it has to reroute, sir. It cannot travel the diagonal without rerouting, and it will take minimum 4 moves to cross the entire diagonal. So rerouting means going to some other place and coming back to the diagonal, which means 2 moves, and the whole diagonal takes 4 moves. So we need at least 6 moves to reach the other horse.
Okay. Yeah. That argument's pretty much right, because like to basically, as it said, like to get here itself takes 4 moves. So like I'm just repeating the argument they gave. To get here takes 4 moves, and then to move this one diagonal length, we'll have to like do some sort of like reroute like this, and that's another 2 moves. So in total, this takes us like the 4 moves to get here plus the 2 move reroute somewhere in the middle. So it takes us 6 moves is what the argument was. I'll give you like a slightly more mathematical reason as to why this is true. Is there something you guys noticed about the lengths of all the paths?
Sir, can you repeat?
Is there something you guys noticed about like the lengths of all the paths that we saw today, or like saw for this problem?
So I have observed that if the night is in the dark color, it will always end up in the light, then vice versa.
White, black, white, black, white, black, white.
Yeah. So basically, all our solutions were of even length, right? Because if I do one move, my knight is at a light colored square now, right? And then after my second move, my knight is now at a dark colored square.
Yes, sir.
Makes sense, right? Yeah. So basically, after an odd number of moves, I'll be on a light colored square, and after an even number of moves, I'll be on a dark colored square, right? That's okay. And because we want to go from a dark colored square to a dark colored square, our path will have to be of even length. Like if you remember, all the paths that we wanted to see were of even length. Like we saw 6, we saw 8, we saw 12, and we saw 24 path lengths, right? So we know that if we have a shortest path, the shortest path can't be of length 5, right? And so either the shortest path is of length 4 or it's of length 6, right? And we can just use the argument that like one of our friends gave, which is that it can't be 4 because the most direct way to go here is through this. And to remain on the diagonal, every 2 moves you can only travel 3. So after 4 moves, you would have only traveled like 6 out of the 7 blocks we need to travel on the diagonal. So we can't reach it after 4 moves, and if we do 5 moves, we'll be on a light colored square. So 6 is the lightest, 6 is the minimum number of moves required to get to the opposite corner. Is that okay? You guys hear me?
So I've heard that the knight can cover all squares without repeating any square.
Yeah, that's the next question we're going to see.
Sir,
First, yeah,
sir, I have a question. Why
okay,
in the previous slide,
yeah,
when you
yeah,
showed,
this,
yeah. So why do you say it's only 4 or 6? Because can even be 12 or 14 or something like that.
we want the smallest number possible, right?
Yeah, but the smallest number, why can't it be like 12? Why do you take only 4 and 6
Because
as the first one?
we already had a path that was 6 long, right?
Sir,
So we know
Uh-huh.
it's at most 6. We already know that.
Okay.
So it has
sir,
to either be 2 or 4 or 6 since we know it's even. And like we can see that 2 and 4 won't reach it in time.
So you just try it out and then take the
Yeah.
smallest path and compare with it. Okay.
Yes. Yeah. Go ahead.
sir,
Yeah. Yeah.
So normal, like, so
One
did you have
second.
any?
Someone else had a doubt. Yeah.
sir,
Oh,
Yeah.
sorry.
sir, I found that each, like if we put the another knight on the before diagonal, then we will have 5, so the number of ways 5. If we put on the second last diagonal, we have 4 as the highest smallest number of ways in which we
Yeah.
can reach. So I found that the lowest number of ways in which we can reach the knight in each case is n minus 1.
What is n here? Like you're saying the length across the diagonal?
Yes.
Uh, that's okay. So if I have it here, right? That's 1, 2, 3, 4, 5, 6, right?
So that's what I wanted to say.
But I can reach there in 4 moves, right?
Yes, sir. N minus 1.
But there's 6 here. Unless you're not counting the last square. If you're only counting the 5.
Yeah.
But then like if you put the knight here, it's 1, 2, 3, 4, 5, 6, right? And we saw it take 6, so it's not n minus 1.
Oh.
So your thing is it'll actually either be n or n minus 1, whichever is an odd even number.
Okay.
So like that's a nice observation, but it'll be n or n minus 1 depending on which is even.
So what I said is, so if you
Hmm.
go from A1 to B2 and then later you go to C and then you later go to D4, it actually takes you to 2 moves. So on the night, in the first place, the night was in A1. and then later it came to d4, and I took 2 steps, and in between there are 2 steps between. So I think that the number of like the length in the diagonal indicate the path.
I mean, yeah, there is a relation, but like also this only works for greater than 3. But what's it called? The relation is there, but the relation only works. So there'll be like 2 cases, right? Because if it's like a multiple of 3, you can see that you can just keep like jumping directly, right?
Yeah.
I didn't
But
understand.
if it, sorry,
Yeah, it
what?
should be more the greater than multiple of 3. I get it.
Yes,
It has to be an even number of moves.
yeah. It'll always be an even number of moves because if you see the entire diagonal is dark squares, and only if you do an even number of moves will you end up at a dark square again.
Yeah.
But like as to what they were saying, but like if I wanted to go somewhere like here, right? Like here, then I'd have to go something like this, or yeah, that's like my only option. So I'll have to go 4 moves just for traveling to.
Get it, sir. Thank you.
Yeah.
No, sir, there is a shorter part of 3 moves.
Okay, tell me what the path is.
No, sir, there isn't. For another.
Okay. Okay.
Sir?
Does anyone else have any? Yeah.
Yes, sir. So if the like place between the two knights along the diagonal, so now it's 6. Suppose it's odd, then suppose you move the knight to G7 or something, then there would be like 5 places
Yeah.
in on the
Hmm.
along the diagonal. So I noticed if it's odd, then you could get to the night in like a easier way that it's
Yeah. Like if it's odd, you can just like
yeah you
do
can
this
go
and this and then this and this. Yeah.
yeah like 4. So you
Yeah.
can get 2 spaces ahead of
Hmm.
So
It's not odd. That's the thing. It's multiples of 3 because if you see like the knight travels like a 3 cross 3 thing every 2 moves, right?
uh-huh
So like every multiple of 3, it just keeps going and going.
oh
Yeah. Someone else had something to say?
yes, sir. So
Yeah.
I'm Abhinav, and basically I have noticed something that if n
Okay.
is greater than 3, and if it is an odd number, that is in this scenario,
Hmm.
odd number of squares between it, that means the moves is n minus 1. If there is even number of squares between those two knights, then it is equivalent to n.
If it's n is greater than 3. Greater than 3 or greater than equal to 3?
Greater than.
Okay. I could put it there.
Sir, I've noticed something that the number of squares between the two is the number of moves required in the diagonal between them.
Yeah. Abhinav saying something similar. One second. Let me just clarify Abhinav's thing, confirm if it's true. So, assuming this is on I9 or whatever, that'll be like 1, 2, 3, 4, 5, 6, 7 squares. And
No,
you're
sir,
saying you
6,
can.
sir. Yeah, we are not including the last square. We are including these 6
No,
only.
I'm assuming this is on I9, not on headset.
Oh,
Yeah.
okay, sir.
1, 2, 3, 4.
Sir, in
4, 5, 6. Yeah. Yeah, what Abhinav is saying is right. So, Abhinav, can you just repeat what you said for everyone?
Okay, sir.
One more
So
time? Yeah.
if n is greater than 3, that is the number of spaces excluding
N is,
those two
yeah,
knights.
this is what we're counting as N.
Yes, sir. And if n is even, then the number of moves is equal to n. If n is odd, the answer is n minus 1. That means the number of shortest moves.
Yeah.
sir,
Did everyone get that? Yeah.
Sir, you first kept the horse and B in A9, right, sir?
Yeah, I9. I was imagining it over here. Yeah.
There we actually can go there in 5 moves itself, sir. From G7, we can straight away go to A9, right, sir?
No.
We don't need to take a reroute, right?
No, that's like still a black square, and here's a black square, right? Like we can only go like this. Because like if this is G7, this will be I9, right?
What, sir?
So like if this is G7, this would be I9 or something like that, right? And we can't go directly. We can only go like to the left or down.
Sir, but isn't the that A9 would be situated in G8 in this, sir? Like for like
No,
here.
it would be like diagonally this way,
Okay.
right? Because we're just extending the diagonal, right?
Yes. Okay.
Yeah. Okay. Does anyone have any more questions or observations, or can I go to the next thing?
Sir?
Yeah.
So, like Abhinav said that this formula works like n or n minus 1, but why does it actually work? Why is it true for everything, even if you keep it on Z26 or something?
Okay. So first, okay, let me just give everyone else like another interesting problem, and then I'll start explaining this. So like you guys can like choose which you want to do. Either like listen to this explanation or continue with that problem.
Okay.
So since someone else had like already mentioned, this was the next problem. You basically have a knight on the bottom left corner again, and this is the problem. Yeah, you have a knight. Actually, you can start on any square, and you want to go visit every square of the chessboard exactly once. Is this possible? And if it's possible, try to find me a path. Okay?
It's possible.
Yeah, then try to find
Not
me a path.
possible.
Okay, then you try to prove why it's not possible to me. Okay?
But there's a special pattern. It cannot be done in any pattern.
Yeah, so find me the pattern. And also like see,
So can you show the chess?
yeah, 1 second. Let me just finish explaining the question. So there's one more sub question hidden within this, which is once you finish visiting every square, can you come back to our original square? Did everyone understand that?
No, sir.
Okay, so I
So
have
for
a knight
coming back to our
somewhere
original
over
square,
here. Okay.
Sir, for after visiting every square, for coming back to the original square, we can repeat
No,
the
we
square.
can't repeat. We have to still like by the time I visit my 63rd square, it has to be from like from the 63rd square. I should be able to come back to here.
Okay.
Okay. So let me just repeat the question using the chessboard. I have a knight somewhere here, okay? And every time I move the knight, I mark all the old positions. So like I go here, and then I go here, 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 here. And like once a position is marked, I cannot go back to it. So like from here, I can't go back to here. I have to go here. And then say I go here, here, and then here. Okay. Now from here, I can't leave this because both of these positions have been visited. So this is not a valid solution. Okay. And my question right now is there a way to do this such that you visit every single square? And my second question is there a way to do it such that you visit every single square and with your final move, you come back to your original starting point?
Sir,
The
it is
starting
not
point can be
possible,
anywhere on
sir.
the chessboard.
Sir, it
Okay?
is
So
not
may I try?
possible. Sir, it's possible.
Okay. Sure. 1 second. Someone said it's not possible first. Who said it's not possible?
sir, can I try to do it?
Okay. If everyone agrees it's possible, like if someone says it's not possible, I would like to hear them first. But otherwise, you can start it.
Sir, it is not
I
possible. Not possible, sir.
Okay. I will. I'll come back to why Abhinav's formula works after this question. Then, tell me why it's not possible.
Sir, it's not possible because if you're traveling to any corner, you'll always get stuck there, sir.
Okay. Then why don't I just start at a corner?
Then when you're traveling to another corner, you'll get stuck.
Okay. So assuming I'm starting here, okay, I travel here, then I go here and I come back out, right?
Sir, then in the end, there will be when the board is almost full, sir. The corners, when you go to the corner, you'll always get stuck, sir.
I just This is a path where you don't get stuck, right?
Yes, sir.
So like after this, I can go like here. Sorry.
So the path should be symmetrical.
Something like this.
So path should be symmetrical
One
across the
second.
board.
1 second. I visited all 4 corners without getting stuck, right?
Sir, then you will get stuck later, sir. Because the
Yes,
paths
but
from all corners will close in on you, sir.
yeah, but like, why would I get stuck? Like, you have to give me a valid reason, right? You can't just say I will get stuck.
Sir, I just tried it out, sir.
Sir, you have stopped in.
Sir, now if you go to the edges, you'll get stuck, sir.
Sir, you have
Huh?
stopped in E3, sir.
Yeah.
So you go to F5.
F5. Yeah.
Then you go to E7. Then you go G8.
No,
And then you are
G8
stuck.
gets you stuck. Yeah, I mean, then I can just go here and do this then. Like, why will I take a move that gets me stuck?
So when you're G also you can go to H6.
No, but here's my thing. Like, I wasn't trying to get a solution here. I'm just trying to show that you can visit all corners without getting stuck. So, is there any other argument for why it's not possible?
So can I tell the solution?
Sir, it's not possible.
1 second. First, I'll hear out everyone who says it's not possible. Then I'll hear out any potential solutions. Yeah, tell me. Why do you think it's not possible?
Because apart from A1, there are not equal the number of moves you have to go is odd, sir, but it can go only to one white square and one black square. So there are 63 squares to be covered. But if the start and end point are same, it may be possible.
Yeah. Repeat your argument. Sorry.
That because apart from this, you will have the 31 31 black squares and 32 white
32
squares.
white squares. Okay.
But it's short, sir, so you cannot have that type of moves here.
Okay. Assume I just have these 2 squares. Okay. There's only 2 squares on the chessboard. If I play this like that's valid, right? And I had one white square and no black squares.
Yes, sir, but the number of moves is out.
Yeah, because we're only visiting 63 squares here if you don't include the starting square. So like the number of moves will be odd here. Because we're visiting one light square extra, so we will have an odd number of moves here. Okay. Does someone have a solution you've properly written down?
Sir, can I tell?
Yeah. Where are we
So
starting?
first, the same area, sir.
Okay.
So we go to C2, then A3, and
Are we doing
no,
this?
not like that, sir. Not like that, sir.
Okay.
B1,
Okay.
then we go to 3C,
Okay.
then back to 2B, yeah, sir. Then we go to C1,
1
yeah, like that.
and then B3.
Yes, sir. Then we got
And then
that. Then we go maybe 5A, sir. And
okay.
yes, sir. 4C, sir.
4, T4, okay.
Then we get that middle square covered, sir. No, not that, sir. I mean, like
Oh, you wanna?
the
Yeah,
other
sorry,
middle
sorry.
square, sir.
1 second, sorry. You wanna go here, here, here to cover this up, and then go back out,
Yes, sir.
right?
Yeah,
Then?
yes, sir. Then we go to 5C, sir. Then we go to 6A. Yeah, sir. Now we cover that, sir. Then we come
Doing
out.
this.
Yeah, like that, sir.
Okay, and then we do this.
Yes,
and then
sir.
we go here, I'm assuming.
Yeah,
Or
yes,
where?
sir.
Okay.
Then we go to 6D, sir.
Okay.
Cover that middle spot up, sir. Then I think we have to go to
So then we can go to
sir,
D.
I think we can go to 8. Yes, sir. 8D.
Okay.
Then we can go to 6E. I think, yeah, 6E. 1 second, sir. I think I
Now,
have
if you go back here, you won't be able to get out.
Yeah, sir. Okay, sir. I got an idea, sir. We can go to 8F.
No, like you can't. Like the solution doesn't work because when you go back in, you can't come back out.
So can we go on one square more than once?
No, you can't. You have to visit every square exactly once.
Yeah.
But I think we can do all the other squares and then come back to B8.
Yeah,
Sir,
that's one way of doing it.
in the chat.
No.
Sir, I found a way how to move the knight in all 64 squares.
Okay. Whoever is telling this, like, think about it again. I like your approach, but like, you just need to like either like the other person said, you need to like go through everything else and then come and visit this last.
Yeah, okay, sir.
Yes, sir.
Yeah. Someone else tell me your solution.
Sir, I found
Answer in the chat.
Sir, I found one, sir.
1 second. Apparently, there's an
I
answer.
mentioned my answer in chat.
Yeah. 1 second. I cannot seem to find it. Can you just say it out loud? Because there's way too many messages right now. Anyone who has a solution like fully written down and you've sent it to me in chat or something, just say it out loud because I can't. Like, there's way too many messages there. I can't find any of your messages.
Yeah, sir, I have sent in chat.
Don't send it in chat. Like, tell it out loud to me because I can't find the message in chat.
Sir,
Yeah.
actually, sir, it's not possible, sir, because there are 31 black squares and 32 white squares, making it
Okay.
an odd number, and
Hmm.
and thus it will kind of like you get stuck on the second last square and you'll never get to the last square.
Okay. Let's assume our chessboard only has these two. Okay.
Yes, sir.
I play a one move.
The white square that you start on, will that not count because you're traveling to 31 white squares, but you already start on one white square.
Exactly.
So you should be on
Exactly.
32 white squares.
So you'll do 63 moves, but you'll end up actually visiting all if you include the starting position.
So we will not be able to cover the whole, as we will only be able to cover only some and not even number, as at least one will be left, as we will be stuck there.
Yes, but why will it be stuck there according to you?
So in that condition, we will be like stuck on all the sides, and we will not be able to travel to like any side.
Yeah, but like what is the guarantee that we will always get stuck somewhere? Like just because we haven't found a solution where we get stuck doesn't mean we'll always get stuck, right?
Sir, it can be possible also and impossible also, because in the starting in the first move we are covering two boxes, but after each move, after that, we are covering only one move.
Okay, like let's forget the 31-32 thing. Let's just assume this one is like given to us to begin with, and we're just doing 31 and 32 in 63 moves. Okay? Like that doesn't really matter if you're counting or not counting the starting square. That doesn't affect whether a solution exists, right?
Sir, I know the solution, sir. Right.
Okay, go ahead.
Sir, C2.
C2.
Sir, and then A3.
Hmm.
C4.
Hmm.
5. Like that. Now go to C8.
Hmm.
Now go to E7.
Hmm.
C5.
We can't go back here, right? This is already visited.
No, D5. D5.
Oh, D5. Okay.
And then E E E3.
Okay.
And then D1.
Hmm.
And then now do F2.
Okay.
And then H3.
Hmm.
H3 and then F5.
Hmm.
Like that.
Okay. And
And then go to F8.
okay.
Go to E6.
Hmm.
And then go to G. What is that?
So we can do D4, so we can do D4.
4. Yeah, D4.
Okay.
And then you can go to B3.
Hmm.
And then go to C6.
Okay.
And then go to D7.
Hmm.
And then go to B8.
Okay.
A6.
Hmm.
C7. E8.
You kind of have to visit the corner now. If you don't visit the corner, you can't, like, you'll have to visit from here and then you won't have an escape, right?
Oh yes, yes. Then corner,
Can I tell, sir?
Hmm.
corner over here. Then
Sir, it will start
Okay.
in A1
One
and end
second, one
B8.
second, one
Can
second.
I tell the solution, sir?
Someone else is telling a solution. Wait.
A4
A4,
and then C3,
C3.
B5 or something, and then D6, and then that middle square which is B7. Yeah,
Hmm.
and then D8.
Hmm.
Now go to F7. Go to the corner. Now E5, um, G G4, G. Now go back to H6.
Hmm.
What else was I type here?
These are your only moves.
Yeah. Go to F6
Hmm.
and then go to G3,
Okay.
E2.
If you go E2, you'll never be able to visit the corner because, like, you're basically stuck. The solution doesn't work because, like, as soon as you come to G3, you have to go to the corner and then you can't leave because both of these are blocked.
Sir, he will also not reach 8E.
No, this is still open, so you can, like,
Sir,
instead
if
of
he,
going G3, you can go like here and here, but then yeah, you can't exit from E8. You are
sir,
like,
but he can't.
you can't
He
exit it after you visit it. Yeah.
can't.
Sir,
Okay.
sir,
Sir,
Yes.
sir, I found out why this isn't happening, sir. This is because the edge squares next to the corners, the edge
Hmm.
squares that is in the leftmost and rightmost files and topmost and bottommost ranks, the
Hmm.
ones the edge squares right next to the corners have a have when the knight travels to them, there is a the the vertices have an incident degree of 3, which is an odd number, which gets
Okay.
passed on to each square later on, and
Hmm.
then when you come to the very last square, that problem uh,
Hmm.
stops you from getting getting to the very last square and completing your task.
So you're saying because of that you won't have a solution.
The parity is creating the problem, sir. If it's a bishop, if it's a bishop also,
Uh,
it will not do because it can only travel on one type of square. But if
yeah.
it's a queen, it can do it, sir.
also a rook, sir.
Yes, sir. Queen, rook, king.
Okay.
Sir,
Okay. How about this first? First, you try to do it for like a 5x5 board, and then we try to see if there's a solution for 5x5, and then we look at 8x8. Okay.
Sir, it is
Uh,
not possible in 5 cross, only in 6 cross 1.
why is it not possible in 5x5?
Because the number will be odd in
Okay.
5 by 5.
And
And that's why it's not possible.
no, yeah, there'll be
Sir,
like
And there will be
13
one
black
left.
vertices and
Yes.
12 white vertices, but like you can't start at a white vertex. You're right there. You'll have to start at a black vertex, but you will be able to get a path. You won't be able to come back to your original starting point, but you will be able to get a path.
Sir,
Yeah.
what we can do is like we can see where all the knight can move and check if there's an exit, sir. So we can move to that square and take the exit, and then for that exit again we can check where the knight will go, where it has an exit, and we can keep on be doing like that to fill in all the squares, sir.
Yeah, that's a good approach. That's quite similar to how we will be seeing one of the solutions. So let's do this. We're almost out of time. We have like 20 minutes left. So I just want to I'll introduce like one or two more questions, and I'll leave you to think about them. Yeah.
Sir, can I please explain?
Sir, I found a way how to move the knight to all the 64 squares.
Okay, good.
So can I
We'll
say?
we'll discuss the solution in the second session. Is that okay?
Okay, sir.
Because I have some other problems. I just want to like give you the problems, and then we'll discuss all of them. Like I'll go through all your solutions in the second session.
Okay.
Okay.
Okay. Thank you, sir.
Yeah.
Sir,
Yes.
sir, can you like create an assignment or something for us where we can submit our answers, each one of us?
Yeah, sure. Yeah, I'll do that. Okay. So that's the night's tour. Like this is what we were mentioning. So there's two kinds of tours. One is where you visit all the squares and you end anywhere you want. The other one is where you visit all the squares and you come back to where your start position was. Okay. Okay. I will not be spoiling the solution. Let's look at the 8 queens problem. Has anyone heard of the 8 queens problem?
Yes, sir.
Yes, sir. Me.
Yes, sir.
Yeah. What's the 8 queens problem?
It's basically
We have
like
to arrange
you have to arrange 8 queens on the chessboard so that they can't
attack each
Attack
other
each other.
immediately.
Yeah.
Sir,
Exactly.
no queen should be on the same line, diagonal or sir.
Yeah. Exactly. So basically, I want us to try to find a solution for this as well. And also we'll be trying to count the number of solutions there are. Does that make sense? So for this, we'll just be doing what's it called? Yeah. So for this, I want you all to like draw a chessboard or like pull up like just open like a board editor online, and then I want you to try placing queens, and I want you to give me as many different solutions as you can. Because the task we're going to be trying to do today is we're going to be trying to count how many such solutions there are. Okay. Again, this is something we'll be seeing in the next session, like the solution. But I want you to, I want us to try it now.
Sir,
Yeah.
Sir, I have
I
a
have sent you
solution.
the solution
It is
on the chat.
called the
Please check
thing.
the chat.
I can't check the chat. There's too many messages there right now. What
Sir,
solution
I
did you
have a
send there?
question for visiting all the 64 squares.
Uh, uh,
It's an image,
sir,
sir.
I
Of a
think Atar's
Okay.
solution is wrong.
Yes, sir. Because in
Because two
One
queens
second.
can attack
Or
each
in the
other.
straight line.
yeah, even in
One second. Let me
rows
check. Let me check. One
RC and
second.
in EC.
Sir, H7 is attacking C2, sir.
Yes, sir.
That's
There are two queens on a straight line.
And rows.
A1 is attacking D4. A3 is attacking
Yes,
F3.
they attack each other. Like two pairs of queens can attack.
Yeah. Both the images I've received are wrong. Okay. Uh, let's let's try to. Let me finish framing the question and then
Sir, I
we'll
have got an answer for 8 queen problem.
Same, sir.
again A2 and H2 are attacking each other. Okay, I'm gonna stop checking chat. Let me try to finish what I want to finish and then we can discuss it. Before we go, someone said you had a question about the 64, like the night store problem, right?
Yes, sir, I have a solution.
Okay, solutions we'll discuss at the end. I'm just going to make an assignment and you guys can submit your solutions there, but I'll also discuss it later. Okay, like I have a second session with you guys. We'll discuss all the solutions in the afternoon session. Okay. Yeah. So does everyone understand the 8 queens problem?
Yes,
Are there
sir.
any doubts?
Yes, sir.
Sir, I have found the answer for that.
So I also got the solution.
Okay, again, I'll make an assignment. You guys can like
Six, sir.
submit all your solutions. I'll go through all of them and let you know. Okay.
Sir,
Yeah.
sir, are there actually different solutions for this challenge? Like more
Yeah.
than
There's
one.
there's more than one solution. Yes.
Okay.
Yeah. Okay. So there's a third question I have. So I'll just state this third question as well, and then I'll let you guys go for your next session. I'll send an assignment in like the next 15 minutes, and then you can solve it whenever. I'll give you comments on your solutions. Okay?
Sir, I have tried this puzzle, sir.
The domino puzzle.
No, what?
Are you talking about 8 queens or the new one I'm talking
This
about to talk
domino
about?
puzzle, sir. I have already done it, sir.
Okay.
I know the answer.
So you continue with the 8 queens then. Let's not spoil it for other people. Okay. For everyone else, we go back to our friendly chessboard. I have a chessboard, except I've removed these two corner pieces. Okay, actually no, I'm reusing these two. I've removed these two corner pieces. Okay. Uh, and now I want to place basically. I'll just go. Sorry. So I have these dominoes that are. I have these dominoes that are like. Yeah. I have these 1 x 2 dominoes. Okay. And I want to place them all across the chessboard. Like for example, if I place them like this or something, I can like make a 2 x 4 chessboard and then like do it again. I can make an 4 x 4 chessboard, right? So we want to make a chessboard. I'm drawing a smaller version, but like we want a bigger version. Uh, we've removed these two corner pieces. Can we arrange the dominoes in such a way that we can cover the entire thing? Is the question.
Can you say?
Sir, we can't do diagonals, right?
No, you can't. You can't place the domino diagonally. You have to
Okay.
place the domino like either like this or like this.
Vertical or
Vertically or
horizontal?
horizontally. Yep.
Sir, actually, I have tried the puzzle.
Okay. So
I
then you
think
think
we
about
done
the other
this
two
with
puzzles.
Ashwin sir.
So can it overlap?
Sir, it is not
Wait, was this
possible.
covered yesterday?
Sir, it is not possible as if you remove the two corner squares, then in the side columns there is only three. Even if you put like you can place the alphabets A, B, C, D, and 1, 2, 3, 4. And then A1, A1 and B1 can be there. A2, B2, and A3, B3. And then if you keep it vertical in the side and then again vertical, then there will be 3 plus 1, the second square from the top,
I mean,
which
you
will be
can.
remaining. The square will be remaining.
we can do something like this, right? Even if there's 3 here. Again, this is a 4x4. Our question is for 8x8, not for 4x4. Like, I just drew this because it's easier to draw, but we are thinking about an 8x8 chessboard. 1 second. Did Ashwin sir cover this last time? Because someone said I did this with Ashwin sir. Like, they did this with Ashwin
So
sir.
it was like a game.
So now
That
it was like a game, sir. Like not exactly removing the two corner pieces, sir, but we have to play a game like where we keep a tile and
Okay.
and they and we want to place the last tile wins. Like that we had a game, sir. But in that
Okay.
game we did not remove the two corner pieces, sir.
Okay, so yeah, that I know that's a different question, like puzzle. That's a game. This is a separate puzzle. Okay. Yeah.
Sir, this is not
Sir,
possible, sir. This is
it's
because this is an 8x8 board, and
Okay.
removing two corner tiles would make the files and ranks in the fourth square of the chessboard.
Okay, 1 second. Let's just go
Second,
back to 8x8 instead of 4x4.
sir,
But yeah, continue with
in
your
next
Making
explanation.
it an odd number, making it not possible, sir. An
Uh,
odd number cannot be covered by an even number. Odd numbers are not divisible by 2.
I mean, yes, I know odd numbers are indivisible by 2, yes, but here's the thing. You're saying there's an odd number of things here, right?
Yes, sir. Throughout the fourth square, it's fully odd.
But I can just do something like this, right?
Sir, but a domino covers exactly 2 squares.
Yeah,
In
like
that
I'm
way,
I'm denoting an arrow as a domino, basically.
yes, sir. But even
Like
that
I
is not
don't have
possible
to do
because the
only
dominoes
horizontals,
arranged in
right?
the file will not do, sir.
Huh?
yes, sir, if you are going to continue like this, sir, the arrow in the sixth will have to go in
I'm
the.
not saying I will continue like this. I'm just saying the fact that there's a 7, only 7 at the top doesn't matter. I'm not saying if you go like this, there will be a guaranteed solution or anything like that.
Sir, there will be 7 in the top and 7 in the bottom, sir. Due to that, we cannot do, sir, because like if you are going to continue like this or do anything in this, the remote pieces will
Okay,
not be
I
able
can
to.
just do this as well. Like,
Sir,
no,
sir, then
sir, it is
A7.
still not
Sir, then
possible.
how will you do A7?
Sir, I did
A7, I'll do
write
like
it in the
this.
paper.
Sir,
I got
Then I
two
can do
squares
this.
diagonally remaining, sir.
Okay, again.
Yes, sir.
Try to find a solution for this. Don't like
one black and
just
remove.
shout out the first argument you can think of. Like, think about it. So do most of you think this is possible or not possible?
It's
Sir,
not possible.
I don't think it's possible
Not
because
possible. Not possible. Impossible.
Not
Okay,
possible.
Argument. Why?
okay,
Impossible.
yes. If okay, so like most of us seem to agree it's not possible. Does anyone think it's possible?
impossible.
It's not possible because
Sir, I think it's
Okay,
possible, but I've not tried it yet.
okay,
Sir,
sure, good.
I
Then
just
try it.
felt
Possible.
Uh, yeah, like
sir,
anyone who's saying it's not possible, give me a reason why you think it's not possible.
Sir,
why
it's not possible because when we remove
what we
opposites
have
of a
seven
chessboard,
and
we
bottom
remove
of
two.
the seven, sir.
We remove two of the same colors, and when we are
Okay,
arranging the dominoes, because it should be adjacent and it should be horizontal or vertical, we should always arrange it with one end of the domino at black and one end in white. So by removing
perfect,
two whites, we'll have two extra blacks left. So without diagonals, it won't be possible.
Yeah, because
perfect, exactly.
black and white.
Uh, did everyone understand what they said?
Sir. Yes, sir.
Okay, can you repeat your argument? Like your argument's fine, like that's the correct argument. Just repeat it so that everyone can hear it.
So when we remove two of the opposite corners of a chessboard, we remove the same colors. And when we are arranging dominoes in horizontal or vertical manners, one end will be in black and one end will be in white. So by removing two whites, we'll have two extra blacks left, which do not have a pair. So without diagonals, we won't be able to arrange it.
Perfect. Did everyone understand that?
Yes, sir.
Yes, sir.
Understood.
Yeah.
Not
Any?
really.
I
Okay.
also found the
So
same.
basically, what they're saying is that we have 64 squares in total, right? And 32 of them are black and 32 of them are white. I'll write it here. We have 64 total, 32 black and 32 white. Right. Now we've removed the two corner squares and both of them are white in our case. Right. So we're left with 30 white. No matter how I place the domino, it will cover one black square and one white square. Is that okay?
Yes, sir.
So what ends up happening is each domino will cover one black square and one white square. So after I place one domino, this will become 31 and this will become 29. And then 30 and 28 and so on. Right. So in the end, we'll end up left with two black squares that we cannot cover no matter what, because unless we place it diagonally, no matter where we place a domino, it will always cover one black and one white square.
Sir, there'll also be a push to the next row because one of the top row, there's one the A8 will be removed. So there'll be a
Okay.
push to the next row. So we can't do it at the last row also because there's another square which is removed.
So this argument, we're not even talking about rows and columns. We're just counting the number of black and white squares. Like this works for like any size chessboard. Like you can take a 100 cross 100 chessboard. If you remove the opposite corners, this will still work.
Yes, sir.
Did everyone get this, or does anyone still have a doubt? Yeah, go ahead.
Like instead of the dominoes can't be in the shape of the diagonals, so like only if we cut it will we be able to.
Yeah, either you'll have to place them across like along one of the diagonals to like cover two blacks, or like the other option is you just cut it, but then you're trying to cover it with like one cross one, and that doesn't even make sense, right?
Yeah.
Like that's
But,
just like trivial, but yeah, those are your two options. Yeah, perfect.
Sir, if we take one black square and one white square, will we be able to cover the whole chessboard with dominoes, sir? Like we take
Yes.
one black and the white up below it. Will we be able to cover the whole board, sir?
Yeah, you can. Especially for like the case you
Can I
said, where
say
if it's
why
just
it is
this,
not
right?
possible for keeping the dominoes after removing the corners?
Yes. Do you have like a different argument to the one I gave?
Sir,
It is not possible because if you remove the two opposite squares, see the dominoes can cover only one white square and one black square. So it can cover 31 black squares and 31 white squares. But in any of the color, one square will be remaining.
Almost. But because we're removing opposite colors, right? Opposite corners, they'll have the same color, right?
So it will be, if you remove the two white squares, then it will be 30 white
30
squares
and
and 32 black squares.
32 black squares, and then
So
you can
you
just
can,
say you'll have two black squares left. Exactly.
Sir, but we are
and
going
it
to
will
take
be
one
in the
black.
diagonal. The two black squares will be in the diagonal, so it cannot be covered.
I mean, they don't have to be in the diagonal. Any two black squares on the chessboard, it will work. Like there will be two black squares left somewhere on the chessboard.
Sir,
Yeah.
sir, but if we are going to take one black and one white, below which is like adjacent to each other, then how can we do it in a 5 into 5 square? It won't work, right, sir? We're going to have an odd into odd square. It won't work when we take two colors of the same of different colors below each other, right?
Okay, let's assume those two are gone. I can just do something like yeah, 5 into 5 you can't cover it anyway because there's only an odd number of squares to begin with, right?
Yes, sir.
Yeah, like this only works for an even number of squares. Like 5 into 5 you'll have to remove the dark square and then you'll be left with an equal number of white and black. Like 5 into 5 is just completely separate case. This only works for an even number of squares.
Okay.
Sir, for this, can we use the logic that 62 is not divisible by 3 and the domino takes up 3 spaces?
Our domino takes up 2 spaces, right?
A domino takes up 3, right? You said it takes up 2 adjacent spaces.
Yeah, so like if this is my domino, that's 1 and 2. Like
The
1 and
domino will
2.
also take up 1 space itself, right?
No, just
Oh,
this.
okay, sir. Also, sir, if the corners weren't removed, would the puzzle be possible?
Yes, because you can just do this.
Okay, sir.
Like
So,
place them parallelly along this thing and then you can just cover every row. Yeah.
so what
Also,
if
sir, I
it's
think that. Oh, sorry.
so what if it's with a 5 by 5 square or something?
Yeah, like someone asked, 5 by 5, the problem is there's 25 squares in total, right?
Yeah. So like, what if you remove just one square or something, one
You'll have to
corner?
remove whichever color has more, but then you'll be able to do it. Like for example, if I take this 5 by 5 square, there'll be 13 blacks and 12 white squares, right?
Yeah.
So if I remove one of the
So
black squares, then it's possible.
so you just remove any of the corner squares because all the corner squares have the same
Yeah,
color.
exactly.
Sir, we
Sir?
will end up in the same case. If we take one white square, right? So in this 5 by 5, we remove one white square, we'll end up in the same case of 2 black squares will remain, right?
No, because now you'll only have 12 black and 12 white squares.
No, sir. What if I don't take this black square and take one white square, sir? I remove one white.
Yeah, then you'll have 2 black squares left over. Yeah.
Sir, just a quick heads up.
Yeah, I saw it's 10:15. Yeah.
We are at
Okay.
10:15, so we can extend it for questions, but if there is nothing else in the lecture itself, we can just formally end this.
Yeah, I mean, like, I can just like shift it to my evening session, like afternoon session. I'll just continue the lecture then. So if you guys have questions, you can continue now. And like you asked for this thing as
I
well.
just had
So
a question.
okay.
Sir, when you gonna upload the assignment?
I'll send it in uh, like, can the TS tell me like what medium are the assignments usually sent in? Like, do you guys have like a group or something where you just send it?
There is a
We
Google
have
Classroom.
classroom. Google Classroom, sir.
Uh, okay, I'll send it by like, because I have a session right after this for the senior batch as well. I can send it by like 1 or something like that, or like
Uh,
12:31 ish, around then.
and I have a question for like these. I didn't get the assignment for Kavita ma'am's class.
Kavita ma'am session assignment has been posted. Please do check your Google Classroom. Hridayana will post his assignment on his own time. He also has other commitments today.
Yeah.
But he'll mostly post it by today, okay?
Okay. Thank you.
All right,
Thank you.
then the session itself has ended. So those who don't have questions can leave. And if sir has time, we can take questions if you stay back.
I'm free to take questions for like another 5 to 10 minutes. So if you have questions, stay. Otherwise, you can go. Yeah.